Continuing on with our discussion on work and energy, we now have conservation of energy. Energy is a conserved quantity. It is subject to the principle of conservation of energy. For an isolated system, when we say isolated system, it's just the system. We don't consider anything outside the system. If the system is just, say, box A and box B, then there's nothing else but box A and box B. Nothing outside the system. We only have those two objects. You have an isolated system. For an isolated system, the conservation of energy principle holds that 1. Energy is neither created nor destroyed and may be converted from one form to another. Energy is neither created nor destroyed. If the energy of the system increases, that additional energy must have come from somewhere. The additional energy did not just simply appear out of nowhere. If the system loses energy, that decrease in energy, that energy lost must go somewhere. It does not simply vanish into nothing. And you have to take into account of that additional energy source and that energy that was lost. Energy may be converted from one form to another. For instance, you have mechanical energy, you have kinetic energy, and you have potential energy. Potential energy may be converted into kinetic energy and vice versa. Kinetic energy converted into potential energy. If we have a system of two objects, the kinetic energy of object 1 might be converted into kinetic energy of object 2 and so on. Converted from one form to another. Number 2, the total energy of the system is constant. Since the system is isolated, there is no change in the total energy of the system. E is equal to constant. Total energy E is equal to constant. Doesn't matter whether you are looking at the initial case or the final case, the total energy is the same. So, E is equal to constant is equal to E1 is equal to E final. Now, if we're just talking about motion of the object, the type of energy concerned is just mechanical energy. So, if we let E be total mechanical energy of the system, initial mechanical energy of the system is equal to final mechanical energy of the system. So we have initial mechanical energy of the system is equal to final mechanical energy of the system. So initial mechanical energy of the system, add all the kinetic energy for the initial case, add all the gravitational potential energy for the initial case, you have the initial mechanical energy. And do the same thing for the final mechanical energy. Add all the kinetic energy for the final case, add all the gravitational potential energy for the final case, and the total is the final mechanical energy of the system. You have conservation of energy equation. Now, if there is the presence of an external force whose work done will increase or decrease the energy of the system, this added energy or removed energy must be accounted for. So we can adjust our equation for conservation of energy for an isolated system. We can adjust this by adding the work done of the external force. So we have the conservation of energy equation wherein you have the presence of an external force that will either increase or decrease the energy of the system. One example of an external force whose work done decreases the energy of the system is friction. Another example of an external force that can affect the energy of the system is the applied force whose work done will either increase or decrease the energy of the system depending on the direction of the force. You will recall that depending on how we apply force, the work done will either be negative or it will either be positive. So, depending on how the force is applied, the work done will either increase the energy or decrease the energy of the system. So you have two equations for conservation of energy to consider for a totally isolated system and for a system with an external force affecting the system. Now, it's best that you memorize or simply take into account this equation and simply remove the work done by the external force if there is no external force, and the equation will reduce back to the original equation for conservation of energy for an isolated system. And that's it for now. In the next video, we'll continue our discussion. We'll look at a few examples wherein we apply the conservation of energy equations to analyze the system to solve the problem. So once again, that's it for now. Thank you for watching.